All right, 4.3, rational exponents and exponent properties. A couple things to remember. Remember, you can separate radicals. So if you have two radicals or two numbers being multiplied together inside a radical, you can separate them. And you could also combine them. If they're separate, you could combine them into one radical. So to go back and forth with that is really useful. You could do the same thing when you're dividing, right? So you could separate this as two radicals divided by each other, or if you have two radicals divided, you can make it a 1. Well, if that's true with radicals, then it's got to be true with exponents too, because the radical is really just the 1/2 exponent. So if you have x to the a and y to the a, this is just some number to the power of this number a, whatever that is, and y to the power a. You can write this as x times y to the power of a. You can do the same thing if they're dividing, right? So you can combine it, and so one fraction here, all to the power of a. These things are going to be really useful in simplifying some of these problems. I will tell you right away, though, there is a typo here. This should not be 81 in practice 1. This should be 27. Okay. Let's go ahead and do example 1 together. I'll show you how we can use these properties to simplify this. The first thing I notice is that they both have the same power of 4/7. So that tells me I could write this as 256 over 2 to the 4/7 power. Well, 256 divided by 2 is 128. And 128 to the 4/7 power, this really is like saying the 7th root of 128 to the 4th power. So we just need to know what do you get and multiply by itself 7 times to get to 128. Most often, the numbers you're going to check are just 2 and 3. So let's just see if 2 works. And you could just go in your calculator and you could just say, what is 2 to the 7th? Or you could do 2 times 2 times 2 times 2 times 2 times 2 times 2. All right, that's 2 to the 7th. And yeah, this actually is 128. So the 7th root of 128 is just 2. All right, let's keep going then. So that means this is just 2 to the 4th. And what is 2 to the 4th? Well, 2 to the 4th is 16. And so this whole thing just simplifies down to 16. Again, just using my rules and just simplifying it down. All right, try practice number 1. Remember, that's not an 81. It's supposed to be a 27. Try that on your own, and then unpause the video when you're ready to check your work. All right, so I saw they both have the same power of 3/2. And so I can combine that as one statement, 3 times 27 to the 3/2 power. 3 times 27 is 81. This is like saying the square root of 81 to the 3rd power. And you could put a 2 here, but you don't have to, right? If there's no number in the crack, then it's just a 2. So the square root of 81, that's 9. And 9 to the 3rd power is 729. That's it. All right, let's go on to the next one. So there's some other rules to remember. When multiplying expressions with the same base, you could simply add the exponents. X to the a times x to the b, that's the same thing as x to the a plus b. Let's talk about y real quick. Let's say I had like x squared times x cubed. What is this really saying? This is really saying x squared, that's x times x. And x cubed, that's like saying x times x times x. Well, how many x's do I have total? I have 5. So this is the same thing as x to the 5th. And now you can see 2 plus 3 is 5. So that's just one example to show you how that works and why that works. So that's a rule that we can use. And the same thing is true when you're dividing, or similar concept is true when you're dividing at least. And that is that if you're dividing with the same base in different exponents, it's kind of like, remember we can make this a negative exponent, and so then that's like adding a negative, which is just like subtracting. Another way you could think about this is we could use the same numbers. Let's say you had x cubed over x squared. Well, this is really like saying x times x times x over x times x. Well, you could see these x's would cancel out, these would cancel out. You would just have x to the 1. Well, that's the same thing as x to the 3 minus 2. 3 minus 2 is 1. So hopefully you're starting to see why these rules work. So if you're multiplying with the same base, you can add the exponents. If you're dividing with the same base, you can subtract the exponents. So that being said, let's simplify example 2 here. Before we can do that, though, we want to have it in the same form. This is in exponent form and this is in radical form. So let's put them both in exponent form. So we got m to the 3/5 times m. Remember, the 2 would be on top, and the number in the crack goes on bottom. That's all there is to it. Well, this is the same thing. Remember, I can add these exponents because it's the same base. So this is like saying m to the 3/5 plus 2/5. Well, that's easy because they already have common denominators. 3 plus 2 is 5. So this is like saying m to the 5/5, which is just 1. So this is just m. That worked out nicely. Let's take a look at practice number 2. Again, I want you to try this on your own, and then I just want you to unpause the video when you're ready to check your work. Okay, so we're just going to go ahead and, first of all, I put them both in exponent form, so we get 2/3 and 5/9. They have the same base, so that's just like subtracting, so I got 2/3 minus 5/9. But they're not common denominators, so I make common denominators by multiplying them both by 3. This gives me 6/9. And 6/9 minus 5/9 is 1/9. So you could write it as v to the 1/9, or you can write it as the 9th root of v. Either one, they mean the same thing. All right, now we're getting somewhere. Now, what if they ask us to solve an equation that's got a bunch of exponents in it? Well, let's think about this. Let's do example number 3 to see how we could attack a problem like this. They want us to figure out what k is, and that's all fine and good, but we need to get the left side to look just like this so we can figure out what the k is. So the first thing I see is I can actually write this as p to the 5/2 minus 2/5, right? Because they're the same base, so I can just subtract the exponents. And this equals p to the k over 10. All right, these are not common denominators, but I could get common denominators. I'm just going to multiply this by 5 over 5. Multiply this by 2 over 2, and so that would give me p to the 25 over 10 minus 4 over 10. And if those are common denominators, 25 minus 4 is just 21, so I have p to the 21 over 10 equals p to the k over 10. Well, now you should be able to see what the k is because they both look like they're in the exact same format, so k must equal 21. Alright, now that we've done that, I want you to try practice number 3. Very similar problem, but you're going to have to get them both in exponent form first. Give it a shot. Unpause the video when you're ready to check your work. Alright, so we're going to rewrite this one as an exponent. That gives us p to the 1/5. That means we have the same base with different exponents, so we could just add the exponents. They add nicely to negative 3/5, and so we see that the k must be equal to negative 3/5. Very good. Let's go to the next page. Alright, the following equations are true for any positive integer n, and h is a constant. And we're trying to figure out what h is. It doesn't matter what n is, we're just trying to figure out what h is. Well, I see 2 roots with the same degree, so I think that means I can write it as 1 root and just make this 6 over 7 times 21 over 2. Still equals the nth root of h. Well, now I see I could take a 7 out of 7 and 21. There's 3 7s in there, and there's just 1 there. I could take a 2 out of 6, giving me a 3 and a 1. So, this simplifies rather nicely. 3 times 3 divided by 1 times 1, that's just 9. And so, we can see, we could actually do algebra if we wanted. I mean, we could raise both sides to n. But you really don't need to. You should be able to see right away that the 9 and the h are in the same spot. Therefore, h equals 9. Boom. Pretty easy. I want you to do the same thing with practice number 4. They're just dividing here instead of multiplying. It's all the same. Give it a shot. Unpause the video when you're ready to check your work. Okay. So you should have seen that you could write this as 1 square root. And you get 12 over 36. 12 over 36 is 1/3. And so now you see the 1/3 is in the exact same place as the h. So 1/3 must be equal to h. Okay, one more problem here, and this one is this is probably going to be the challenging one from this chapter. Simplifying rational exponent expressions advanced. So let's take a look at example number 5. This is a doozy. Practice 5 is a little bit easier, but example 5 is a hard one, so I thought I'd do that one for you guys. The first thing I'm going to do is I'm going to see if there's anything that I can combine into one term because they have the same exponents, and I'm going to write this as in exponent form. So the top's going to be 99u to the 9th, and that's going to make a 3/5 exponent. And since these are the same, I'm going to write this as one exponent. So this is like saying 11u times 3u to the 4th. And hopefully you see now that these are also really the same exponents. And so we can make this 99u to the 9th over, we could go ahead and multiply this together. 11 times 3 is 33u to the 5th, because there's another u here, u to the 1 times u to the 4th. And this whole thing is to the 3/5 power. Well, now everything inside the parentheses is going to reduce nicely. 99 divided by 33 is 3. And u to the 9th divided by u to the 5th is u to the 4th. And I don't really see any way that we can simplify this anymore. So that's it. There we go. See? Not that bad. All right, try practice number 5 on your own, and then we will be done. Okay, the first thing I noticed is these are the same base with different exponents, so that means I could just add these exponents. And 5/8, oh, I also rewrote this as in exponent form instead of radical form. 5/8 and negative 1/8, that's really 4/8. And 4/8 reduces down to 1/2, so I really have 27 1/2 over 3 to the 1/2. Well, they're the same exponent, so I could just write it as one expression. And 27 divided by 3 is 9, so 9 to the 1/2 is the same thing as saying the square root of 9, and the square root of 9 is 3. Boom. This whole thing is just 3. All right, guys, don't forget to write a question that you have from your notes, and I'll see you guys on the next video.